So in this problem, mean and standard deviation values are given. See, the mean value is 70 and the standard deviation is 5. So by using these two, we have to count first probability for students having less than 65 marks and greater than 75 marks and 65 to 75 marks. If I indicate X as marks in that particular subject or marks in examination, then this less than 65 means X less than 65, and this is X greater than 75, and this is in between 65 to 75 marks. So we want to calculate the probability of X less than 65. So we want to calculate in this question probability that X less than 65, and second question probability that X less than X greater than 75, and third one we want to calculate probability that X is in between 65 to 75. First we will use the normal distribution standard normal variate Z formula to convert into variable Z. So what is that formula? We have Z is equals to X minus mu by sigma. In this problem, mean mu is given as a 70 and standard deviation is given as 5. Let it be equation 1. Now this is the first question. First question is a probability that X less than 65 or greater than 65, less than 65. So X less than 65 means by using this equation, this comes as Z is equals to 65 minus 70 divided by 5, and you simplify minus 1. So saying X less than 65 is same as of saying probability that Z less than minus 1. Now how do you calculate this probability Z less than minus 1? By using normal distribution table we have to calculate the area. Let me indicate this point Z is equals to minus 1 in normal curve. So in this case Z is equals to minus 1, so it will be left to Z is equals to 0, and we want to calculate probability that Z less than minus 1. Now Z less than minus 1, what are the values? Z less than minus 1, it will be left to Z is equals to minus 1 line, right? So this is the area required, left to minus 1 up to minus infinity. This is the required area. How do you get this area? By using this normal curve. Now the question is, we know already the total area which is left to this Z is equals to 0, Z is equals to 0 to plus minus infinity, we know this is 0.5. If you are able to get this portion, that means area from 0 to 1, if you know this area from 0 to 1, then easily you can get this required area by subtracting from total 0.5 whatever the value you get it for this one. How do you get from area 0 to 1? Area from 0 to minus 1 or minus 1. See, normal curve is symmetric about that is equals to 0 line. So area from minus 1 to 0 is same as of area from 0 to plus 1. How do you get the area from 0 to plus 1? If you look at the normal distribution table, okay, this is 0 to 1, right? This is always the areas from 0 to particular point. This 1.0, and when you add these this 1.0 and this 0, yeah, 0.3413, so which is 0.3413. 0.3413. This value is 0.3413. Now this required area can be obtained by subtracting 0.3413 from 0.5, that is let me write it here, 0.5 minus 0.3413. So in this portion, I'll write it here, 0.5 minus 0.3413. When you simplify this, it comes around 0.1587. This is the probability, but actually in the question, out of 1000, how many such students are there? That is the question. So out of 1000 such students, how many students will be marks having less than 65 or greater than 65, less than 65? So in this case, you need to multiply this probability value with that sample size 1000 into 0.1587, approximately it comes as 158.7, 158.7 or 159 students will have marks less than 65. Similarly, the second question is probability that uh, mass more than 75, because I have taken X as marks in the examination, so more than 75 is nothing but X greater than 75. We will convert this into Z variable by using the formula X minus mu by sigma. Because the mean mu is 70 and standard deviation sigma is 5 in this problem, so we will get it as 75 minus 70 by 5, which will be plus 1. So saying X greater than equals to 75 is same as of saying Z greater than plus 1. Now how do you calculate the probability Z greater than plus 1? By using normal distribution table and the curve of the area under the normal curve. Let me draw the normal curve first. Now we want to calculate probability that Z greater than plus 1. So if you draw the Z is equals to 1 in normal curve, this Z is equals to 0 point, Z is equals to plus 1 will be right side of this line, Z is equals to 0. Let me write it here, Z is equals to plus 1. Now if the question is Z greater than plus 1, that means values of Z which are greater than plus 1 will be right side of this Z is equals to 1 line. Here say Z is equals to 0.8 will be left to plus 1, Z is equals to 1.2 will be clearly right to this plus 1 line. So based on that, we will decide this is the portion required and portion area required for this problem. Now I know the area from Z is equals to 0 to the end plus infinity, this total area right to Z is equals to 0 is 50% or 0.5 or 1 by 2. Now I want only area from 1 to infinity. So if I know this portion, I can subtract it from the 0.5. So how can you get area from 0 to 0.1? This area will get it from normal distribution table. Area from 0 to 1 from the normal distribution table, 0 to 1 it is 0.3413. So this area will be 0.3413. Let me take it as 0.3413. Now subtract 0.3413 from 0.5 minus 0.3413. You'll get this required area, which is 0.1587. This is the way how we will calculate. The same last problem also you can do in the same way.